Okay, guess we'll get started. At this point, I think most people are watching not live, which is fine. I know it's kind of crazy. So anyway, this is going to be the last Zoom section or session. Next week, Monday, is the exam. And today I'm going to go over how to do homework 8, and I'll just give um, just a little bit of the information about the exam. I'm not going to do an exam review just because I think at this point you can probably go back and look at um, previous lectures and previous Zoom section or sessions. And I think that's at least one advantage of this online um, format is that you can go back and view things again. However, if there is something you don't understand and you want me to go over, let me know and I can either do like another Zoom session or go over it in a different way. So let's start with homework 8. So basically these are problems like I usually do with homeworks. It's not exactly the problems that are in homework 8, but they're like similar ones. So if you follow the same protocol, you should be able to do the homework. So the first question here is a compound is composed of 40% carbon, 7% hydrogen, and 53% oxygen, and has a molecular formula mass of 180 grams per mole. So we're supposed to be the first thing we need to do is figure out its empirical formula. So we're supposed to figure out basically what it is in 3 steps or so. So I think for this part, I'm going to use my pencil here. Oops, am I sharing? Okay, we go. I think I forgot to share the screen. Sorry about that. Okay, let's see. No, it's not that one, but I will find it. There we go. This one, I think. Oh, there we go. Okay, so let's see. Yeah, so this is a sample problem. And the problem is we've got a compound with 40% carbon, 7% hydrogen, and 53% oxygen, and the molecular formula mass of 180 grams per mole. And we're going to figure out how to do what it is. And it takes multiple steps to do that. So I know this is quite a challenging problem, but if you break it down into the component parts, it's not too bad. And you basically do exactly the same thing for the homework. And if you look here, like it's carbon, hydrogen, oxygen, which I think is also true for the homework. And this is actually there's lots of different organic compounds. Those are compounds with carbon that have slightly different ratios. So they just make a good example. So that's why I chose this one, but this shows a different one. This is a different compound than on the homework. So let's get my tools here. Okay. All right, so the first step in solving a problem like this is we have to calculate the empirical formula. Just a second. Okay, so, and to do that, we know that we've got, this is like percent by mass. So basically what we have to do is, because carbon, hydrogen, and oxygen have different molecular weights, we can't get the ratio directly from this information. First of all, we have to convert to moles. So what we're going to do is, it's 100%, we're just going to assume that we have 100 grams total. So if we had 100 grams total, we're going to have 40 grams of carbon, 7 grams of hydrogen. So I'll write these over here, carbon, hydrogen, and oxygen. We're going to have 53 grams. And if we add that up, we'd get 100% because, oops, not 1,000%, 100%, because basically, or 100 grams, because that's the only elements in this compound. So now that we have this information, we've got grams, we've got to convert to moles. So what we do is look up on the periodic table the molar mass, and I'm not going to switch back and forth to the table because it's kind of awkward on the Zoom session. But if you look at carbon, it's 12 grams per mole, and that might be becoming familiar. Some of these like carbon, hydrogen, and oxygen, we use all the time. So at some point, you don't have to memorize them, but you probably will just because we use them so often. So 12 grams per mole for hydrogen or for carbon. Then when we got 1 gram per mole for hydrogen. So that's the lightest element. It's only got 1 proton, no neutrons for the most common isotope. So it's 1 gram per mole. And then for oxygen, it's 16 grams per mole. So, and basically what we do is, they wrote that down, but now we have to divide. So I always write down my units and look. So, well, how do I know that I have to divide in this? For one thing, it's kind of just the way this problem is solved, but more importantly, if we look at, it's grams here, and if we divide by grams per mole, grams is going to cancel and moles is going to come out on top, and we want moles. So we know that's what we need to do. So that's 3.3 moles. And then for this one, that's just 7 moles. 7 divided by 1 is 7. And then we've got 3.3 moles of this. So that's basically, if we had 100 grams, that's how many moles. Now we need to figure out the ratio. And this is the part that I think is a little bit confusing. But basically what we want to figure out is, like, if there was like a 1 to X ratio, what would that ratio be? So what we do here is we find the one that's in the lowest number, so 3.3, and this should be a decimal point too. So 3.3, let's say if there's one of those, let's say we had 1 mole of those. Right now we have 3.3 to 7 to 3.3, but we want like a, basically a whole number, smallest ratio, which is the empirical formula. So 3.3, if we divide that by 3.3, and then also we're going to just divide everything by the same thing, because we want to divide, we have to keep the same ratio, right? If we divide by 3.3 all 3 times, we end up with the same ratio, but then we're going to end up with 1 carbon. And then if we do this, 7 divided by 3.3 is about 2, so 2 hydrogens. And then 3.3 divided by 3.3 is again 1 oxygen. So we've got a ratio of 1 to 2 to 1. So this is what this is telling us. It's 3.7 to 3.3 to 7 to 3.3 is the same as 1 to 2 to 1. So that's what you're figuring out when you do this part of this problem. So then we just write down from this information the empirical formula, which is C, and then H, there's just 1, so we don't have to write the 1. And then we have H2 and then 1O. So that is the empirical formula for this. Oops, and I gotta use my mouse. Okay. And all right, and this thing's incredibly annoying because it doesn't scroll with the screen. So I think I'm just gonna erase. All right. So we have, I'll just rewrite the empirical formula here. CH2O. The rest of that information we don't need anymore. We're just using it to get this. So that's the empirical formula. And then now we're going to calculate the empirical formula mass. And basically a formula mass is, it's the same as any formula mass. It's just the mass based on this formula. So for, we have a carbon, so that's 12. So again, that's the molar mass, 12, and then there's 1 of them. Plus hydrogen is got a molar mass of 1, and there's 2, 1, and then there's 2 of them. And then oxygen is 16, and there's 1 of them. And then I'll put in brackets, so I didn't feel like writing it over and over, but I do like to write my units, so I'm gonna put them in brackets. That's gonna be grams per mole. And then when we add that all together, the formula mass is 30 grams per mole. So that's what we get there. Now we need to figure out the molecular formula. And if we go back to the top here, it says it's got a molecular formula mass of 180 grams per mole. So in this case, so I'm going to write that down here. So we've got 180 grams per mole. So that's the molecular, I'll just write FM for formula mass. And then we've got 30 grams per mole. And that's the empirical formula mass. And basically what we do is, again, this is kind of a ratio. So if we divide, we end up with 30 grams per mole. So that is I'm sorry, we'd end up with 6. I was like looking at the wrong part of my sheet here because I do write it down because it's hard to talk and think at the same time. So 180 divided by 30 is 6. And then grams per mole cancels. So we have 180 divided by 30 equals 6. So basically what this is telling us is that the molecular formula is 6 times larger than the empirical formula. I realize my handwriting is not good on this thing. So basically what we have to do is we have to multiply each of these subscripts in the formula by 6. So that's going to be C6, H, and then 2 times 6 is 12, and then O6. So this is a molecular formula for a glucose and probably some other things, but glucose is a common sugar. So this is how you would figure out the molecular formula from this information. And for the homework, you have a very similar one. It's going to be a slightly different ratio. It's not glucose, it's something else. But it's basically, if you follow these steps, you should be able to do it.